Yes, sir.
Yeah. Okay, let us stop. Let us start.
Okay.
So I'll give you some relations, some formula. So first formula is, so these are actually formula. Okay. So number one, can you follow me? So relation connecting Young's modulus, what? Young's modulus, Mach modulus, and Poisson's ratio. So the formula is, you have to remember this formula actually. E by 3 into 1 minus 2 sigma. K equal to y by 3 into 1 minus 2 sigma. So this is an important relationship. Did I tell about this thing earlier also? Did I mention about this thing also earlier? So connecting Young's modulus, rigidity modulus, and Poisson ratio.
So, sir, we can
Yeah.
that poison we can use as a mu, no, sir, mu.
So sometimes it is mu, sometimes it is sigma. But it should be clear to you.
Okay.
Whatever you use,
Okay.
there is no problem. It should be clear to you. Okay. So let me write this. So Z is equal to E by 2 into 1 plus sigma or mu, whatever it is. This is another relation. Number 3, K G sigma. You can write mu also. So Poisson ratio sigma is equal to 3K minus 2Z by 6K plus 2G. Then number 4. So it will be definitely Young's modulus Young's modulus, Bach modulus, and rigidity modulus. So that, see, these equations can be written in different format. So if it is uh, asked in your MCQ, so it may come not in this form. It may come like, suppose this part you can take it here, then k is equal to that way also it may come. So basic thing is that the relation between kg and sigma, you should remember this, and if it is simplified, if it is in a some simplified form, that you have to tackle actually. Basic concept is relation between what? So the relation between them is E is equal to kg 3k plus z. Okay. So these four formula are very important. Just try to solve some problem. Excuse me. Okay. So now we'll deduce mathematical definition of mathematical definition of strain. Suppose this is point A, this is point A prime, this is suppose U. Are you following me? B prime. Can you follow me? And from here to here, this is delta x.
কি বমি সমি করলো নি পাচ্ছেন না থেকে হ্যাঁ
It is well known fact that strain energy vary from strain
এই সবটা বেড়ে খাইছে সবগুলা খুলি
fact that strain vary from. Yes, someone's mic is unmute. Point to point. Let us consider point A. Let us assume hello, can you follow? Oops, 2.8 is hello by displacement of u. Also say B moves B plus delta u to be this. Del u is the amount of stretch amount of stress sorry, so it's not stress, this is stretch. Stretch takes place takes place within the rigid body. Therefore, epsilon is equal to limit delta x tends to 0 del u by del x is equal to du dx. Suppose equation number 1. For a
So, yeah,
this will be partial differentiation. Let's do one thing. It's a little bit complicated diagram. So maybe I will send you the figure. You don't have to draw this. That figure I will send you in photo. Okay. A little bit complicated. You write in addition to normal strain, an element can also experience a shear strain. So as shown in the figure that I will send you. This inclines the sides of the deformed element in relation to the plane. The definition of shear strain. definition of shear strain associated with the XY coordinate is gamma xy is equal to gamma yx is equal to del phi del x plus del u del y. So this is 4. It will be equation number 3. So this is valid for small angle of deformation. Similarly, you will get yz zy is equal to del w del y plus del phi del z. This is 1 and gamma xz is equal to gamma zx is equal to del w to del w del x plus del u del z. So you can put it equation number 4. So 3, 4, 5. Okay. So equation 2, 3, 3 and 4.
So
Yes.
if you scroll down, so we can see. If you scroll down, up, so the little off,
Okay.
you can
Okay.
focus. And you can just post.
Okay. So equation 2, 3, 4. Three, 4. Where was I? Equation 2, 3, 4. No. 4. Okay. Are called equation.
So can you please explain that how the formula will be this came? Because
Yes. Yes.
like for
Yes. I'll. Yes.
if I x we have differentiation differentiation u with respect to x, but in down we can see that
I'll
partial differentiation of by yes
explain.
yeah okay.
Or equation of compatibility. See. Okay. This is over. Okay. The thing is that I could not provide you the figure. In the figure itself, actually, it is clear, but still, I will tell you. See, for example, we take okay. Let us go to this equation. Suppose equation number 3. Okay, so listen carefully. So here you see only xy plane is there because there we have written the definition of shear strain associated with the xy coordinate. So there will not be any z coordinate. So strain here, strain is actually indicated by gamma. Okay, so gamma in xy plane is equal to gamma in yx plane. Means your if you see the strain in the xy phase, okay, and in the yx phase, that means yx phase will be your top phase and xy phase will be your front phase. Why? Because the first, as I told earlier, the first subscript will indicate you the particular direction, particular coordinate or particular uh, plane, and the second coordinate will show you the direction. So let me draw one small diagram here. Okay, let me try to understand. Suppose this is one. Okay, so if I take x and if I take y, so this top face will be your, the strain in this top face will be your y. Okay, and in the direction of x, and this face, if you consider, it will be your strain on x face xy. Okay, so now as we have derived in the above part, if you look at, in this case we can say the strain as the, this is the change in dimension or change in position with respect to x coordinate, and this is the change in position with respect to y coordinate. Suppose you have distorted one body, so it will be distorted both in x direction and in y direction. We are not considering here z direction, so that will be distorted or that will be d-shaped in both x and y direction. In x direction, the deformation can be partially differentiated with respect to x, and sum of the partial differentiation of the deformation in x direction with respect to y will be equal to your deformation in xy plane or equal to deformation in your yx plane. So this is the figure actually. The small part of the figure I have drawn. So total deformation will be both in xy direction and yx direction. So practically, if I could have shown you the thing, you could have understood better. Okay, so now you can ask me why it is partial differentiation. Okay, partial differentiation is there if there are associated more than one degree of freedom or more than one direction, then it will be always partial differentiation. Okay, but if only one directional deformation is there, suppose in x direction only there is deformation, then it will be your total. You can say then you would have written dv dx, not del v del x. Okay, so since it is deformed in two direction, we have to take the partial differentiation. Means uh, deformation in x direction plus deformation in y direction will give you the total deformation. I think, am I clear, Guru?
Yes.
Not sure?
Yes.
Okay, take on
But what about down?
see, suppose take one example. Suppose you take a matchbox, okay, matchstick box, and try to deform it. So if you push it from one end, you will see that both in x direction, in y direction, and z direction, its dimension will change. You cannot control it to change only in x direction or in z direction or in y direction. It will change in both direction. If you take an example of a sponge, suppose, one cube type sponge, and then you try to deshape it, then you will see that your frame of reference will change. XY coordinate will be changing, Z coordinate will be changing. So that means we can say the information is happening in all the three directions. Okay, so particularly in this case we have taken two directions. Suppose in XY plane, so in XY plane there will be deformation in X direction and Y direction, that is designated by this. We have considered only this phase, we have considered only this phase. So now suppose you have applied force from this side, so it will be now like this. Okay, if you push it from this side, so it will be like this. So originally it was like this, originally it was like this. So I was telling about that figure, so figure is little bit complicated. So now it has shift to here. So earlier suppose it was A, it was B, now it is your A dash, it is your B dash. Now you can refer to the previous figure, this figure. Once again, now you can refer to the this figure. Okay, so this is the case actually happening there. So earlier your figure was like this, and now after pushing it or you reshape it, it becomes like this. Okay, so there is strain both in X direction and in Y direction. This is X direction, this is Y direction. So since there are two these directions are applied or associated, so we have to take partial differentiation plus u del y. This is the deformation with respect to Y direction, this is the deformation with respect to the X direction. That means this point now move from phi to phi dash or phi plus delta phi, whatever you say. Okay, and why partial differentiation? This is actually in mathematics, partial differentiation will come into play when there are associated more than one component, like your partial pressure. In partial pressure, what happened? Suppose this is nothing, huh? This is like, suppose you have a gas chamber. Okay, there are some gas particle like this, some gas particle like this, some gas particle are like this. So if you want to get the total pressure, then you will take the partial pressure of 1, partial pressure of 2, partial pressure of 3, you will get the total pressure. Okay, so more than one component is associated, so it is partial pressure. But if there is a uniform gas, only one gas, suppose hydrogen, then P total is equal to pressure of hydrogen. Okay, so that is why partial differentiation is used in that particular. So Gurung, am I clear?
Yeah, okay. Yes.
You refer to this figure only, you refer to this figure, then you can understand why it is. Because in this direction phi is sent with respect to x, the change in velocity, change in displacement, we, this is not velocity, but this is not velocity. Okay, this is the position change. Okay, so tomorrow class we will take at 3 to 4. Okay.